Hello, welcome to IDC 606, a final presentation. Here we will be presenting magnetohydrodynamics equation solver. So we will be working on this equation to solve. We want to solve this equation. So the first equation is the continuity equation, and the second two equations is nothing but Navier-Stokes equation in conservative form. And these equations are presenting the induction equation, which tells us the change of magnetic field with time. And this will be our generic form of conservative equation of continuity, momentum, and magnetic field, which will be implemented in our code.
For simulations, we first considered 128 by 128 grid, and you can see the parameters that we have used. We considered periodic boundary conditions and initial conditions for velocity field and magnetic field that you can see. For the first run, the total computation time was 742 seconds. And these are the results for the velocity field, and the heat map shows the density, and the streamlines are the streamlines for the velocity field. And this video shows the streamlines for the magnetic field. We computed the kinetic energy, internal energy, and magnetic energy for all time steps. When we added them up, the total energy was conserved, as you can see, and the total mass was also conserved. For the second run, we consider a 256 by 256 grid with the same initial conditions and boundary conditions. This time, the computation took 3,913 seconds. Similarly, we get the uh, plots for different energies, and again, the total energy and total mass are conserved. Now we run the same code on the GPU cluster. We use the Bernard GPU, NVIDIA RTX 3050. We consider 10 iterations for the same initial conditions, and we can see the results. We can compare it with CPU times. As we can see, there's a almost 100 times speed up for larger grid sizes. And we have plotted the n versus 1 by t in a log-log plot. And we can see that the GPU shows a significant speed up.
Here we will do the profiling part. First, we have to know why we need the profiling of codes. Via profiling, we can analyze the performance of program to identify what are the different bottlenecks and how the resources are used, like how much the GPU used, how much kernel is used, and how much memory is used. And it can also give an overall idea of the how the different parts of the codes are flowing, how to optimize a code for better resource use and for better memory for management. It also tells what part of the code is most significant. Like we'll show in the next slides that what functions are the most significant in this code. Now we'll do it using NVDX marker. First we have to install via pip install NVDX. Then here we are importing NVDX locally in each code, and we also importing in NVDX marker in each code, and we have also annotated NVDX marker before each function. Like here I have used the NVDX annotated before time advanced Euler function, and I have colored it with blue color. So in the profiling part, we will see that blue color is used for time advanced Euler. Here I'll show a demo of the NVIDIA Insight. where there is 79.8% kernel is used, 22.2% memory is used, one thread is running, and there is thread ID 27834. This is here we are zooming the NVTX marker part. And the x-axis is for time axis, and this shows the start time and the duration in millisecond, the thread ID in which GPU the code is running. You can clearly see that time advanced single step takes approximately 201.727 millisecond. Time advanced Euler 410 second. This is the analysis summary part. This shows that the computer used is or cluster used is Bernard. This shows the OS used. I have run it in Ubuntu. The GPUs, the thread summary, the environment used, the overview of NVIDIA Insight. Here is the timeline view. Here is the NVTX marker. Here you can see the event part, and this is the time axis. You can clearly see 630 milliseconds, 635 milliseconds. This is just a function, flux derivative. It starts at 1.63 second and ends at this time and takes approximately this millisecond. This is the thread ID. Now, this is the profiling for 128 into 128 grid points using 10 time steps. Remember that NVIDIA Insight supports only for 10 time steps. It takes 1.75 second time interval. This is the kernel used, 76.6%. This is the memory used, 23.4%. And this is the different functions with different colors. You can zoom it and see the bigger version of it. And this is for 2048 into 2048 grid points with 10 time steps. You can clearly see that the time advanced Euler colored with blue colors, and it takes the most of the time, 6 to 4.64 millisecond. And the last is 4096 into 4096 grid points with the same 10 time steps with same initial conditions. You can see this is the most kernel used, 79.8%, most memory usage, 20.2%, time advanced Euler, and this is the time advanced other function. And these are the different code with different colors, different functions with different colors. And here also one thread is used.